All right, let's do this. Here we go. Tom Millman. Thank you, Tom. We got a new follow sound for today. I think I should do a new follow sound once a week. I keep adding them. Chop, chop, mother truckers. So here's where we left things yesterday. Here we are, and we cut. Look at that. So we have the cuts. Uh-oh. That's not right. So anyways, we have a little bit of a problem here. We're going to fix it. I think that might be because I commented out something. It looks good, but we still have like a bazillion things we have to do. Yeah, we didn't queue free. Okay, so this will fix that bug. So, but I've discovered like 10 bugs already. Looks like Tree Sitter broke. I don't know why. There we go. That's Minecraft logic. Raid. Oh, chainsaws, yes. That too. But yeah, we can come here and we can just cut. Now, if we keep cutting, that'll cause the bug. But I think we just solved it. So that the other bug will go away here. So if I do it again, it should just... Yeah. So if we look down, now we have the two cuts. So that's good. But you can see the collisions are wrong. It creates a new collision, and instead of being a cylinder, it does it off the mesh, and you end up with something that's not cylinder based, and it won't roll, right? We want that rolling action. And so what we have to do is we have to take the mesh that we have, figure out where the center point of our cut is, and when we create the new meshes, we give each one a cylinder size that is the exact volume of the original cylinder, just different sizes. So, that's the goal. So all branches in the entire tree structure itself will be made up of a series of cylinders, okay? It's a conceit. And a damn fine one, if I do say so myself. So that I think is our primary focus today. And the other thing we're going to focus on is we're going to have it cut the piece, but once we know that we have the cylinders right. Let me break it down again. When we do the cut here, so you can see, if we look at the tree, you can see right now that it's made up of a cylinder. See that perfect circle around it? It's only got the 4 points on it. That's what we want when we cut. But what happens when we cut is we create a new mesh based off of the angle that we're cutting in. And then we construct, using Godot's system, we construct a new collision mesh, and that's when everything gets all weird. And that's why that has that bounce to it too. So if we watch here, it has that little give. And that's because both sides of the new collision are a little bit larger than the actual mesh that we end up with, right? And so they push against each other, and and that's also why we've seen where if you cut it a certain way, you can end up with a branch just floating. Let me see if I can get a good angle. That didn't do it. But anyways, so cylinders are the key to this, I think. Bugs are weak to chainsaws. So yeah, our problem right now is to get a point on this thing on one of the branches, figure out where we are, and relate that into the scale of the mesh that we're going to create. So, yeah, this kind of sucks balls. I'll say that. Now, we could use, to get started cheaply, let me reopen Godot, because something about Tree Sitter keeps breaking. Does it have a bound struck? Well, I don't want to go down that route because we lose the roll. So if I show you what I mean, if we get rid of our joint and we just throw this guy up into space, and then we start the scene, and we go and look. Oh, he's still floating. Oh, I have the wrong joint. Hang on, before I delete it. There we go. We're gonna delete and run the scene again. He's still floating. That's weird, right? Why is he floating? Why is he floating? He should be falling. Why is he floating? That's weird. Am I stuck? No. He's stuck. Oh. What in the ever-loving? Oh, the mesh isn't bound right. So it fell on the ground here. What? How come? Oh, you know what I did? I moved the mesh and not the transform of the mesh and not the rigid body. There we go. So if we move this up and I do something like, because this is what we want, and I'm just kind of going to show. We're going to kind of rotate it a little bit this way and a little bit that way and a little bit like this. And then we'll go up, up, up. So high. Take a look. Reading rainbow. So here we go. So there it goes. Clunk, clunk. And so it rolls, which you can't see right now, but I can kind of push it. That is critical. And we're only going to get that with a cylinder collision. So that's why I care. And this creates some dynamic elements to the game. Now, obviously, if it's a cylinder body and it has like other cylinder bodies coming out to it, it's not going to roll the same. But other aspects of it will. But that behavior of rolling, I feel like, is really important for organic moments. And also the cylinder, as far as a collision body is concerned, is one of the cheapest shapes we can get in terms of physics. So the more complexity we add to the tree, hopefully the fewer cost overhead that we kind of deal with. Does that make sense? Hopefully that makes sense. And the other reason why we want it to be this way is because when we join the two together, there needs to be no, where the joint is, there needs to be no collisions happening in the first place. Or there does need to be collision, but it's very, it's not that they're like fighting each other. We don't want that. So one way we could do this is if we know the size of our mesh here, can you maybe get the width and the height for the cylinder of what we end up with? No, it's not right. Because when we do this intersection thing here for the mesh, no, because the right now, the way that we're getting the values back, it's just wrong. And you can kind of see it. Let me show you. Can see it in the collision shape sometimes. Like that's fine, but then if I cut again, that one's fine. Of course, now I'm going to try and show it, and I'm not going to make it happen. Damn it. Come on, give me something. I can't get it to happen. Come on. Oh, those two collided with each other. I wonder what's going on there. I wonder if I can I hit it with by jumping? That's weird. I'm not sure what's going on there. We're getting a little bit of roll. It kind of rolls. Well, let me see. Is there a choice for that? So we're doing that's on the, what's it called? Lumber. So we have create multiple convex collisions. That's the function that we're going. And that's coming from Mesh 3D. Mesh convex decomposition settings. There's resolution. Yeah, we have to be careful. Could easily create too many. Maximum number of vertices per convex hull. Max concavity. Hmm. But yeah, I can't figure the math on how to get the difference yet. So we got to figure that out. Yeah, the problem. So the problem is the axis aligned bounding box is sometimes wrong. That's my issue right now. There's also there's also another problem with that, which is, let me show you what I mean. So here's the issue with that solution, because I was thinking that too initially, but this is why my whole stream yesterday kind of died down. Let me explain. So our problem is that we end up with I didn't want to explain this on the stream because it's just kind of a lot to digest, but so we get a cut that's imperfect, right? It's some sort of angle like this, and the other side of the branch has that same angle, right? The problem with getting the axis aligned bounding box is it looks like this. Let me see here. Let me make this full screen, and we're going to say red. It's this. So we can't just use the axis aligned bounding box. Here's the reason why. There we go. So it ends up being like this. It's the shape of our wood plus this space here, so that what it really looks like when they're lined up together is this, and they're overlapping. So if I was to try to build the cylinder off of that, we would be wrong. So what I'd like to try and do is create a point here and then make our bounding box on both ends. The size of the... Does it need to be precise though? Well, if it's overlapping and we have a joint on it, I think what's going to happen is the branch is going to be like doing this kind of thing, like fighting that joint. Right. So my plan is to just find the center part of our laser, get the size this way, get the size this way, and then say, okay, this bounding box should be over here, or this cylinder should be this size over here for this mesh, and this size over here for this mesh. So we end up with like a little bit of a hanging chad situation on both ends of it, but I think it'll be okay, at least as a starting point. So yeah, the problem right now is the axis aligned bounding box is wrong for our, when we do this operation here, this intersection. We get, this is wrong every time. Or not every time, but sometimes we get these like explosions of the size, and it's way off. So that's kind of part of the problem, because what I could do is theoretically just take one and then use that to create the other. So I'm trying to think of like the easy way to say, here's a point on a space, on an object, where right here on this object, how much is on this side and how much is on that side? Is that coffee or our Lord's beverage, Coke? It's Coke. That's why I'm downing it so fast. I've been having withdrawals. Coke withdrawals. Yeah. Yeah, we can. And then we still have to kind of make a decision on it. But the problem still is that for now, that box is wrong. Let me try and get a scenario where it can make it wrong. It's usually when I do these angled cuts. There we go. Look at that. So this collision mesh is built off of the axis aligned bounding box. And when we create the mesh, for some reason we get vertices that go way out like that. So sometimes it can be radically wrong using the CSG operations. But I believe the person, because I'm using someone else's code here, and this is why I'm trying to do it myself now. Uh-oh. Okay, hang on a second, guys. Miss Cricket's trying to get a hold of you. Oh my gosh. So what I think it is, Jacob, I can explain here in a second. It's just, I have to build this myself because I can't trust this other person's code. How do I collapse the chat so you guys can't see it? So I can just show you guys the, here we go. Look at my boy. He drew this. Isn't that cute? We have one of these programmable robots, and he loves it. It's called Sparky. It's his fave. One of his faves. It seems like it left 1 pixel. So I think it's because of the operation called intersection. But even though the mesh is correct in its look from what we did, it's the axis aligned bounding box that for some reason is just complete haywire. And I think it has to do with the fact that the CSG shape operation has already subtracted the side that it's now created a mesh for, the side that got cut and fell. And then it takes the remainder and does the intersection on it. And the intersection is just, hey, whatever's left in this space of this bounding area. And so we end up with this way wrong, even though the mesh is right, the bounding box is wrong. And the last vertices, any vertices that touch an endpoint all together where the mesh is, right? You could imagine a bunch of vertices ending right there, right? Whenever that happens, then all the vertices actually, for some reason, are calculated as ending at the very edge of the bounding box. I think this is actually a bug in Godot. But anyways, I think instead of trying to worry about, or not worry, but try and tackling that, I think if I can ask, because we know initially we're correct with the bounding box. See, if the bounding box ever breaks, we can't ever trust it for any of this. So I think ultimately what I need to do is I have to do this CSG slicing and everything myself. Now if we do everything up until the actual division and everything. So if we skip all of this, let me see here. So I'm just going to highlight all this and cut it out or disable it. And then if we run the code, so we go like we're going to cut, then we can go and see on the scene what what these boxes actually look like. So I go here, I do this. Now we can literally walk over here because I think it creates it right here. So here's what's going on. And I think it put it in the ground because this is much longer, right? Yeah. So let's hide the ground from us when we do this. So ground, we're just going to hide the mesh. So we're going to be floating in space right now. Go over here. Go and cut it. And now if we walk over here, this is where the actual math is happening. Okay, so it still did some of the operation because we're seeing this. If we look at the running scene though, we go over here, remote. Here's the actual combiners. So there's the object, and I can't look at it right now. There it is. So there's object, and then where's slicer? There's our slicer. See, this looks wild. I don't know what the hell this is. I think their math is wrong. Because this looks insane. So how much of the operation have we done? Oh, we did both of them. We don't want to do any of them. We just want to build them out. Let's see what that looks like. Okay, so we put a mesh. It's super thin. Okay. And so we're building this as the thing that we cut with. Now, it's a volume space that is enough to fit that part. I don't know why they make it so big. I don't understand this. Does it go on forever? No. This looks so janky. See, I think they're doing something wrong. So how can we do this knowing what we know about CSG Box? Let's try and do this ourselves first. And we have a scene for this called Simple Modeler. So we have these guys here, and all of these operations, none of these are subtractive. But we can set up any of these to be, so operation, they're all unions, right? So intersection and subtraction are the two that are happening here. Operation subtraction, operation intersection. All of these are unions, so these are all additive. But we could do something like on the box here, we can say intersection, right? And now we just end up with just the meshes that are in the space of this CSG box. And then subtractive means that it's going to take away, right? So now it's gone. And so then we only end up with this other remaining element of a mesh. So let's create two CSG, let's create our branch. So our branch should be object CSG and then slicer CSG. So the way they're doing this, I think, is the way I understand it. Actually, we have a cylinder here, so we can do CSG cylinder. Cylinder. Okay, and we'll delete all this. And we'll have a plain old cylinder here. And we will rotate this some bitch like that. So we're saying 24 sides typically. Anyways, so we've got a cylinder here. And so the way that the slicing works, as I understand it, is we create a shape that is one side of the mesh of our cut point, our angle that we have a mesh that we're using that's the angle of our cut. So if I were to just say CSG box, and I made the box big enough to represent a cut. Now, in this case, it would be exactly perfectly square or perfectly, now we don't want it inside of the other. So if we do subtraction, we end up with what? It should get rid of this, shouldn't it? What about intersection? Let's try the other way. Subtraction. See, now we're subtracting from, okay, so this is taking away from this. So why? This is union. Why? If I choose subtraction, what do we end up with? We still have a perfectly sized. Does it matter our order? Ah, it does matter the order on the scene tree. Okay, so subtraction here gets rid of this side here. And then if we do intersection, we end up with that side. So that's what they're doing. Essentially, they're building a box that is our slice. And then they're doing an intersection for the one side and a subtraction for the other side. What I suspect is going on is that the box is not, it's not right for our needs because we end up with, it's like shaped like the cut, but then it has all this remaining volume to it to fit everything else of the mesh in. And then when we create the resulting mesh, the included in the axis aligned bounding box is this extra space that we have. So I suspect that's why this happens the way that it does. So now we know that the scene tree order matters for this. So yeah, I think at this point I'm just going to build this myself. So here's a question. Here's a how do we do this? How do you do this? Well, okay, so we know the angle. So what are we doing here that is presenting that? Nafir, how's it going? So we have this basis and everything. So we're matching the basis for this cut transform, which is our mesh. So we take the cut mesh, which is like this invisible mesh that we have on the blade of the chainsaw. And then we take the global transform of that and we call that a cut transform. And then we adjust the cut transform to match the space of where we're doing the actual CSG stuff. Nathir, welcoming everyone in with a clap. Oh, we're too loud on our volume there. Sorry about that, guys. Didn't realize it was so hot. Nobody told me. So yeah, intersection creates it on the inside. So we have the face of our square if we know where. And so like if we rotate it like an angled cut, we'll see that same behavior there. See? So it's doing something like this, and then it's scaling the size of the quab to be to the edge here. But the problem is now we have a rotated quab, right? So we have this cube that's rotated, and then we're scaling it in, and that's how we get that axis aligned bounding box to be all kinds of wrong. I'm pretty confident that's what's going on here, right? So is it possible that we can how do we end up with and I think the answer might come in the form of man, I didn't realize the scene tree played such an important role in all this. So here we're combining the so like if we flip this around, I bet we end up with all kinds of madness. Let's try it. Watch, this just fixes it. Look at this stupid Lua error. This is great. Dude, I updated, never update anything. I updated my lazy vim and now I'm paying for it. See, I can't get the tree sitter down. Shit. It's fucking broken. Great. Lumber pieces not declared in current scope. That's weird. I'm not sure what happened there. Okay. So floating out in space. We've inversed the so yeah, it's wrong. So we've verified that the scene, the actual scene order is important for these operations to work properly. So we know that's a truth. Now we're ending up with this crazily sized box mesh. So big it's hard for us to even tell what it looks like. Why is that happening? So we're going by infinite and then we're scaling. So from a maximum, we take an infinite plane as our maximum, and then our minimum is so negative infinite to positive infinite for vec3s. And then we are scaling them down. We take a mesh. So it says mesh. What is mesh? Mesh is the lumber cutting mesh. How often are we using this? Just mesh by itself. Right there. There. And that's it. Aw, look at that. Hmm. Nathir is or me? Nathir's making the rounds. How you doing, Nathir? Your kid's drawing. Oh yeah, he's cooking. So if I took this right now and I saved this mesh, right? So I have this simple system that I made to figure some stuff out. And now we have I should have saved the mesh. What is it called when we save it? New mesh. So here's our new mesh. So if I go in here and I just create a mesh instance, and I take our new mesh, this is what we just made. So here it is. Now, what is the axis align bounding box on this? So this looks right. Okay, so then let's do the opposite. So we're going to say, I'm going to rename this to side A. And then we'll do the other side, which is going to be intersection. Is that right? No, that's the cylinder. It's going to be subtraction. Okay, so this is, I think subtraction is where everything goes. Or is it intersection? It might be intersection where everything goes wrong. Yeah, I think it's intersection where typically everything goes wrong. So then we have all this and then we save it. Okay. And now, for some reason, it takes a while for the scene to update with these changes. So here's our one side. I'm going to create a new mesh instance. And then we're going to load that in. Now, this says it's new mesh, but we renamed it side A. Quick load, side A. Quick load, new mesh. There it is. See, it's complete. And the bounding box looks correct right now. I suspect it has to do with the fact that they're using an infinite plane. And something about that is going terribly, terribly wrong. We have some information that we can use to create a much more rational size of a starting point, which is we could take the axis align bounding box and we could simply double it, for instance. and start from there. And we could use double its size as what we're getting started from. Because theoretically, the most we could ever do is angle something for, you know, like that the CG box here, for instance, would be double the size of the... So, for instance, our cylinder is what? Height of 2, right? So we are the same size. We're equal to the height of the cylinder right now. So if we did some wild-ass cut here, like that, right? We're not right. But if we do 4, if we are 4 starting, now we're well beyond the size of our thing here. And if we get the transform right, which right now it's not, that's not what we want to move. We want to move the box. So if we try to match the transform of our cut somehow, so I don't know. But if we started a smaller size, maybe that would do it. 2 to the 1.41. So yeah, so we have our mesh and we have the bounding area, right? So we can get the axis align bounding box of our current mesh. We multiply, and it would be size of the axis align bounding box size, right? So the mesh that we're using is this right here. And so if we just say max at mesh get ABBA dot size times or 2, let's just try doubling it. But see, now we want, see, we're using space, right? Infinite. So positive and a negative value. So we will do times -2, let's say. Or we will just say negative ABBA. And then we will, I mean, we can make it 4. It doesn't matter. But not starting from infinity, I think, is probably better. Let's just do 4. 4 is probably good. I don't know. Okay. Let's see what we end up with when we try this. So we're going to come over here. And this might not work. Okay. So the problem is we're dealing with an intermittent issue. So these are the worst to troubleshoot. But generally these deep cuts seem to do it. So now we're looking for worst kind of problem in computing and in medicine to troubleshoot. Is intermittent. Ooh, we could do like a nice little weird angle here. That's a cool cut. Look at that. Does anyone else feel like I might be on the verge of a different kind of game? Like with this cutting thing, I was thinking about bonsai trees and how this is more like you're snipping like a bonsai tree. And I was like, you know, that's another possibility. Might end up with 2 games out of this mechanic. Okay, there we go. So it's not as wild, but it's still really wrong. And here the collisions, the endpoints of the collisions are completely off from my theory that it has to do with the endpoints of the vertices in the axis aligned bounding box. But this is wrong. Flat out. All right. So we're going to abandon this for now. I understand more now about how we're generating the mesh. Is it possible at runtime to regenerate the collider? Well, what we might be able to do is fix the axis aligned bounding box size. If we can ask the mesh some detailed information about itself, we might be able to force the bounding box to be different. Because we have this option here, which is a custom ABBA. So if we can ask the mesh itself some detailed information about its sizing that isn't related to the bounding box, then maybe we can just reshape the bounding box around the size of the mesh. Because it looks like we can create our own. The bounding box is more about visualizing in the editor than anything. I don't know that this is a universal. This is the thing about learning game development through an engine. I don't know if the axis aligned bounding box is a concept native to any other engine than Godot. So I'm ignorant to that. But if we go to mesh, so it's in Unity also. Okay. So the problem, so we might have to calculate from the mesh in Game Since Forever. Okay. So we have the get. We have an override for get on ABBA. So we have a function that we can create custom. We can override this that would then, when we call this, we could calculate a different result. So on the mesh itself, though, we can get the surface arrays. Returns array of the vertices. So from the vertices, we can get an array mesh. So we could use that on an array mesh and calculate a new bounding box, I bet. So if we created a new array mesh on this, using the vertices that we get, so add surface from arrays, we give the arrays here, and then primitive type, I don't know what we would set it to. So I don't know what we're getting when we ask for it. But we could then use this to create an array mesh, and then from the array mesh, can we ask for its ABBA? It does inherit mesh, so we could ask for its ABBA after that. And look at this. So we're creating vertices from this, our arrays, array vertex. Oh, this is arrays. Arrays is different than what I'm thinking. Array max. So there must be a special way that this array that it's expecting is built. And we're handing it the vertices, which is just a packed vector3 array. And we put it in an index that's array vertex. So we have to size this array a very particular way before we feed it into an array mesh to then build it out. Space War. Jesus, that's like one of the first games. Isn't that the one that used the, yeah, that's like one of the first games. That's wild. So, you know, a while. Okay. So the thing that would suck is if we find out that for some reason the rendering of the mesh is correct that we slice up and get. But then when we grab the vertices, something about the numbers are wrong. Again, though, if we skip all of this stuff, the problem is the collision. We know now that we can't, if we keep using the same way that we're cutting everything, we cannot trust using the axis aligned bounding box to determine the size of, if we were to insert our own cylinder shape to do this, we can't trust the bounding box from the slicing that we're doing right now because sometimes it's wrong. Why? We're not 100% sure about that. How to fix it? Possibly. So I guess we could try and fix it. Here's what we'll do. Because we can save it when it's wrong. Let's do that. Let's get a bad one and then save it. And we'll have a reference we can work on. Look at that. See, that's why we get that floating problem. See this? See, this is wrong now. See, it's shooting out, and now it's resting on this invisible collision space. And again, that's because we're building out the collision shape based off of the description of the mesh, including the axis aligned bounding box. It's all wrong. You know, what about the old things that are in the games? I can't remember seeing anything new in the past few years. Get a bad one and save it. That's just human nature. If I get a bad one, I can blame, I don't have to blame myself. All right. There it is. Look at this, the box. So you can see the bounding box of the mesh. Look at this, see? See how it perfectly encompasses? This is the mesh, not the collision shape. So this is the bounding box of the mesh. This has to do with the problem of when we generate the collision shape off of the mesh. Something about the bounding box being all screwy is contributing to this, for sure. This type of issue is a later fix. The problem is the joint thing, Jacob. Because when we do this slice, the whole thinking that I'm having is we're going to start cutting into it, but we have to have it connected together in a joint. So the steps involved in what I'm doing is we slice it first, then we glue it back together, and now we have the player cut into the wood, and now we take the joint and slowly release the joint, and then the wood gets bends and bends and bends and bends, just like in real life, and then cracks and falls, and then we release the joint, and then we have that falling element. That's all I'm trying to build here. It shouldn't be this hard, but it doesn't feel like it should be this hard, but physics performs such offsets, I suppose, but it's interesting that it's within the bounding box of the mesh always. So if I save this mesh, we now have a screwy ABBA cut mesh. So now we have this standalone thing, this mesh here, and then we see the axis aligned bounding boxes way out. And this was generating using CSG. Might be funny with how it acts. Yeah. Oh, I see what you're saying. I think we're going to have enough jank just trying to get this thing to work right. Because it's physics, right? The physics part is going to be the fun part. Once, yeah, we're going to have some jank. Jank everywhere. Puzzle, and it breaks puzzles all the time. But yeah, but I still want this particular kind of thing where when you're cutting it, it does a certain thing. So now if I take this, we can show you how this problem is happening without showing the code, right? Create collision shape. So this is what we're doing. Doesn't matter if it's a sibling or static body child. And I'm doing a simplified, I think it's a simplified convex, right? Is it simplified convex? Create collision shape. Child. There we go. So yeah, so we end up with that weird problem where it's just wrong. Now, there might be other ways of creating the collision shape. Try mesh. So now we're accurate, but look at this. This is costly. So this is totally right. So we know that, but I believe in my heart that if the bounding box was the actual size of the damn mesh, if we did a simplified, it wouldn't happen. But here we are. Have you got X inverted? Extend the line. Extend what line? Twice the width? What's twice the width? The cut line? Oh, like if we were to take this space and then flip it. But it doesn't happen. This is the part that's weird. It doesn't happen every time. So like this isn't, it doesn't happen every time, but it seems to happen on deep angles. So I think it has to do with how the cut shape is created. Seems like one of the edges is being tested. Yeah, you're speaking a foreign language. The easiest solution would be to prevent players from making those cuts, right? I suppose if that's what's truly going on, that's a good approach. Yeah, we don't want too deep of a cut anyways. Like, if I can not have that problem happen. No, see, it happened right here, too. Just on a simple plain cut, it happened right here. So we know, if I look at the scene right now, I know that the axis line bounding box of this mesh is going to be enormous. So if I go over to, oops, if I go over and I come over here and I look at remote and we go over the rigid body. So this is the rigid body, but then if we look at the, see that? The axis line bounding box of this mesh is that much volume. In this case, it almost seems to be the entire original size. Just to be sure, if you look at the mesh, there isn't a stray vertex. How could I tell if that were the case? I guess I could turn on, like on this mesh, I could turn on wireframe. So here's the wireframe of the mesh. Oh, look at that. You're right. There's a little fucker. With the normal on, it goes away. Oh, you can kind of see it. It's a little hair. It's the back cut of the mesh. Yeah, so it's the cut. God bless it. Okay. I wonder if there's a way to clean stray vertices from mesh. There might be a way to cull them if they don't have you might be right. Let's see. Get faces. These are all the vertices that make up the face of the mesh. So if we use the faces, we have a packed by 3 array of vertices, and we use that to recreate the I mean, this might suck, but we could recreate the mesh again using the faces, because that certainly is not a face, right? This little hanging guy is not a face. Although it might be. Actually, it might be. Yeah, it looks like it is. Shit. Fuck. Okay. This is why we don't use someone else's code. Because if I had done the mental modeling here to figure this out, I think I wouldn't have sunk in much time on this fucking problem. And I have a much better understanding of this. Okay, so going back to what's actually happening, as far as the cutting is concerned, they're generating some sort of cube based off of our mesh that we have the angle for. It takes that and arranges the cube in a way where it can subtract, and we end up with one side here, and it can intersect, and we end up with this side like this, okay, across the cylinder that we're cutting. So, or the branch in this case. So what we know for certain is that we could scale the cube way beyond the constraints of the existing mesh if we can figure out what face, what side of the cube to put on this angle here to just grow it into infinity. This cube could be infinity big, so long as the one face of the cube is matching the angle of our cut. Then we would have the perfect result, because we wouldn't end up with these like hanging chads. So that's something that we know is an absolute. How do we do that? I don't know how to do that. So one idea, make them opposite. Well, for dummy me, if we could have an origin that is on the side of the face of a quab, and then we could just move that to the position of our and match the transform in our rotations, and then we move that that origin that's one face of the cube against the side where our cut's supposed to be. That could do it. I just don't know how to do that. I don't even know if I'm using the right words when I'm saying that. So for the geometry, is there anything here? Well, it's not the cylinder we care about. It's the angle cut, which is like an invisible mesh that I'm using. The cut face wouldn't. So I don't think we can do anything where I have like a center point, unless I put it inside of a node. Could I do something like this? And it still needs to be above. Now, see, now all the subtraction and stuff stops working. So it can't be inside. We can't use any 3D element of Godot. I'm not sure it's a cylinder. Since it's a cylinder, wouldn't it have normals in all direction? Well, so the cylinder is just a testing ground. I remember having something like this in Algebra 3. The fact that I'm using a cylinder right now for the shape of the tree is not going to be permanent. It's just for me to build something, if that's what you're talking about. And maybe you're talking about something else. If we can get the side of a face, and then we can move the cylinders. Yeah, that's what you said. The cut face would have a normal that ideally shares a positional identity matrix and a transformation rotation matrix in common. It's more targeted than 2Bob. Okay. If we know the size of our cube, I can do this just idiot style. If we just have some maximum possible value for the cube size that's a fixed value, then I think I can do the math myself to go, okay, the cube is this big. We need to cut on this side here. We know that the center point of our so that's everything that's happening here is trying to do that. They're creating the slicer CSG here. They're trying to size it to the bounds of a mesh of a space. And so they're trying to create a cube. I believe it's a cube. So it's a box mesh, yeah. Box mesh. Oh, I see. So it's a CSG mesh. Okay, so they're not actually using CSG box. That's interesting. So they're using a CSG mesh 3D and then putting whatever mesh they want inside of it. I see. What's that about? Okay, so for something like this, then in here we put a mesh in it. Wait a minute. Wait a minute. I think we have a solution right in front of us. Or at least, I think I know how I can do this. Okay, this is stupid. This is a stupid approach, but I think it'll work. This is great. Hang on. I think you guys will like this. This is so stupid. Okay. I am cracking up already. Okay. So here's our player controller. We have our chainsaw here. And now on the chainsaw, if you look at the chainsaw, there's this invisible cut mesh, right? So here's our cut mesh. Okay. What if, because it matches the blade, all right? What if it's just really big on one side? And so I recreate the thing that we're going to subtract and do the other operation on. What's it called? So we subtract and we do intersect, right? So what if I just make it this invisible cut thing, just one-sided and just a huge thing, and then we use that actual thing as what we do subtraction on. Everything would be lined up already anyways. Then, yeah, it's dumb, but I think it'll work. It's so stupid. Okay, so it's so stupid. So, okay, so I love how stupid it is. And then we can guarantee that we can only cut as deep as the blade is too still. So Here we go. So the Y needs to be really big. No, it's not Y. Sorry. I keep getting this wrong. It's the Z. Is it the Z? No, it's not the Z either. Which one is it? It must be this. Yeah. Okay, so then we need to shove this over. So this just needs to be huge. So our Z and our X need to be enormous. So, like, it can go on for quite a while. It doesn't need to be that big, Cricket. Hang on. Let's bring it down a little bit. Let's say like 1,000. That's reasonable. That's reasonable. And then we'll make it super big, tall here. And so we'll just do 100 by 100. How about that? Okay. So now we're going to have this chunky, huge, invisible slicer that we have to get lined up. I don't know how I'm going to do this because I can't even see the chainsaw. There we go. Oh my gosh. Did I get it right? Holy smokes. I think we could move it over by 1. X 49. No, it needs to be less than that. 49.9.
That's cool.
Oh, second with the raid.
Yeah, cool. You think it's cool?
All right, well, we'll do this for
It's
now.
not cool.
I think this is it. This is so stupid. The problem is we don't have an issue of death. Thank you so much for the raid, Greg. Do shout out to Second. Second back on the stream wagon. Working on a Dark Souls of Pin. No, I'm just kidding. It's imagine pinball game, but you can fly around and then become a pinball again. Basically, you have some control over the ball as well, right? And there's flappers, and it's like a level and a stage that you're going around. And so it's a little bit like, it's like pinball controls, but then you have a little bit of freedom of movement added on top of that. So it's almost like you can control the English of the ball in a way. And then sometimes you can just go free, like Dracula turning into a bat is what basically is happening. And then you return back to ball form. We got second is the balls and I'm the wood. And together we form something awful. Okay, so for now, let's go back to a minimum vert count. That feels trivial. The other thought I had was cut it twice. Does that clean the bad verts? I don't think so. I think it has to do with there's like just like some leftovers because of the sizing that they do for their cut is just wrong. I think that's what's going on. I think that's a big part of it. And then I guess what we'll do is we'll have the cut mesh position. So we want to change the mesh. So if we look at the mesh again, and we'll just make the mesh really big too. All right, so there's our invisible cut mesh. So whenever we're walking around, we have this big secret cube following us around. And then whenever we do a cut, we're just going to put this cube exactly where the blade is and subtract from one side and do the opposite on the other of the mesh. And then we end up with, that's our cut. Secret cube, man. Secret cube. Exactly. If it's cheap to cut, it might work. I don't think it will because it's just doing this right here. It's literally like a Boolean operation. It's either intersecting, so it looks like this, or it's subtracting and it looks like this. But doing it like twice isn't really doing anything, I don't think, because it's literally, you're seeing the result of it here. It's a subtraction. It's a mathematical thing where it's when you save the resulting mesh that you end up with the final proof or whatever you want to call it of that mathematical operation. So it's not like you can it would be like I'm going to subtract 500 from 100 or 50 from 100 twice and see if I get a different result. You just wouldn't. I think that's the way to think about it. So like what I mean is if you had 100, two problems on the same page and it was 100 minus 50 and the other one was 100 minus 50, you'd end up with the same result every time. But it is a new collider. Oh, you mean on the collision? So somehow do that on the collision. I would have to turn the collision back into a mesh. So I take the points that we end up on the collision and I have to turn it into a mesh, and then I'd have to subtract that, and then I have to bring it back into the collision space. I think the reason why I'm going to try and avoid that anyways is because we're going to try and build the, not exactly, but like you would do your cut and finish it and then secretly cut it again. I just don't know. When you say a second time, I'm not sure I follow. Like, so you mean we end up with a mesh from our results here, and then we take that mesh, put it in the same situation, and run the subtraction on that. I think that's what you mean. I see. The problem is, I think the problem is right here. I think the thing that we're subtracting with is wrongly sized. And I think this is like the core of everything going wrong here. If we can get this right, then we can get 2 axis line bounding boxes. They're still technically overall the wrong size. What we might need to figure out is this plane of our cut, right? It could be going any way. We need to figure out that space. So this little thing here. So if we have a cut and we're looking at the cut straight, like as though our I-beams are making the cut, we need to get a quab. And then using this, I think we could split the quab in half. And this would be the point where the cylinder is built on one side and then on the other. Well, it's cutting, which is sick to see. I'm going to put you on your phone. Yeah. Thanks, guys. Thank you for the raid. We're working on a game where you cut a tree. I can show you what we're at, where we're kind of at on things right now. Let me go ahead and hide this big old thing. We're floating in space right now. Please ignore that. We don't have a ground right now. Just ignore all that. We come over here, and you can whang. Oh, get child on null. Oh, shit. I've broken some stuff. Oh, God. I'm a liar. People come in, and I instantly just make myself into an idiot. 13 static bodies null. What? Oh, because our slice size is so big. Now I've really screwed things up. You're going to have to trust me, guys. All right? Trust me, bro. Hang on. Let's put it back the way it was so I can just show you really quick. Okay, so here's our old cutting size. Okay, and then we can go ahead and hide this. Now I'll show you really quick, okay? We're in the middle of changing all this because we have some other issues that we're dealing with. Okay, so we can cut the tree, okay? We can cut the tree. There it is. There, it fell on the ground. Okay? And then we can go over here and we can cut it again. And we'll cut it, and then that other branch falls, okay? So the actual cut in the game is going to be more like, we're cutting into the wood, and the wood cracks and falls and all that kind of stuff. But the main thing we're working on right now is just getting the angle of the cut right. And so we've got that going, but then we have like a dozen unresolved issues that are sort of with that. That's good. I spent 2 hours not accomplishing something I've done 70 times. So relatable, Greg. Dude, it's so relatable. Oh my God. Chainsaw cube too large exception. Happens to me all the time. Okay, can we bring it back though? Let me bring the... Can I make the quab? Nope, we're going the wrong way. No, I think I have to do it again. Damn it. Okay, hang on, guys. You gotta trust me on this. To make the chainsaw quab huge again, our quab is going to be 100 by 100 by 100. So that's our cut space. It's a giant quab. And I think we said 50, right? -50. And that got us to the other side of the chainsaw. Yeah. Okay, so now we're lined up with the blade, and one side of the blade has this giant mesh that's going to represent where we do subtraction and where we do, what's the other operation called? I'm always forgetting. Intersection. Okay, so now what we have to do is rewrite a bunch of stuff where we use the information of this quab to then do the math. And so what we're going to do... So Chainsaw has a reference to this, I think. So we already have what we need. Cut mesh? Yes. Okay. So it's cut mesh. And the funny thing is we're already throwing this in down here. So the cut mesh matches. So we could do all of this. We're doing all this like moving of transforms and stuff, and I don't think we need to. Because everything's where we need it to be. So here's what I'm going to do. I'm going to copy all of this and paste it up here. Okay, and then we're going to comment this out. I'm going to believe that I can just figure this out. Okay, so there's our old code. And let's think about this through. So we have our cut transform, which is this global mesh here. So at this point, we think we know that we do not need to do any of this. So all this stuff can go away. Okay, so that can go away. Now, we have the slicer position and mesh size. We don't need any of this either. Get rid of that. Okay, so that's gone. Now we have our two meshes that we're going to create, and this is where we do the operation on the slicer CSG. Slicer CSG is using box mesh new, but we know, for instance, that we already have this mesh right here. We have it, cut mesh. It's just there. We know it's in the right spot where it needs to be in global space, right? So if we just assign, if we have this CSG mesh, and we just give it for its mesh, the cut transform mesh. Well, no, just the cut mesh. Is that all we need to do? Should we just try this and see what happens? The other problem here is cut mesh. We're doing a bunch of stuff for this. We are taking the global transform. And then we're doing a bunch of stuff here. Cut transform. So we're changing ourselves here. Because we're creating these new meshes. Get the slice meshes. So we have mesh 1 and mesh 2. And then we're doing the operations here. And then we output those meshes into those different meshes. Okay. So if we match, the whole combiner already exists. We know the mesh that we're going to cut. Object. Mesh is what? Mesh is the thing that we're cutting. So this can go away. And it goes here instead. So we're using the current mesh that we're cutting of the lumber that we're got our laser beam on. Okay. Hey, you. What do you got? You got something. Can you show me? Can you show me? Odie's Continent Book. Oh my goodness. Did you write all that?
Mama helped me.
Mama helped you? But you wrote all that, didn't you?
I wrote the
Antarctica. Beautiful. South America. Great. You did the same colors. North America. Very good. Europe. Good. Africa. Look at that. All the colors are the same. Australia. That's where the movie is that we're watching.
Oh.
Yeah.
But Australia is where Bluey lives. Yeah.
Australia is where Bluey is. Yeah. And Asia. Beautiful work, buddy. Good job. Give me a big fat hug. You did a good job.
I've been drawing on the ending like a 3D printer.
Oh, I love you.
I love you too, Papa.
Okay. You just stay like this, okay?
No, I want to do my roots.
No, you're going to tuggle with me.
No.
We're going to tuggle all day.
No.
Let's take a nap on the stream together. Let's just take a nap.
No.
No, come on, just take a nap. Let's take a nap. It'd be great. No, come on. It's a sleepy nap. I'd love a sleepy nap. No? All right, fine.
Yeah, do a clap.
Okay, what was I doing?
Amazing.
It's amazing, yeah.
And he's remembering a lot of the names.
He is?
Like the only one that he didn't kind of remember without a small clue with Asia. I could like tell him Asia, but he remembers Europe. Calls it syrup.
Syrup. He calls Europe syrup.
Had to take off this.
That's great. All right. Sorry about that. Brief interruption. Okay, so we are specifying this, so that should mean that we don't have to do the transform. So this cut transform nonsense, where is this happening at? So we're adjusting the transform here. Let's get rid of that. And let's say that it's not a box mesh, it is the mesh of the cut. Dudes, I think this is so much simpler. And it's like my way of understanding it. Okay. And I mean, let's just see if this is right. This could be totally wrong. So, okay, we shit the bed. What do we shit the bed on? 127 value of type. Value type of mesh instance 3D cannot be assigned to a variable type of mesh. 127 cut mesh. I mean, why would I call it cut mesh if it wasn't a mesh? Oh, it's a mesh instance. Oh, see, it's a mesh instance. So it's cut mesh.mesh. That's silly. Oh, and so that means the transform's not going to be right. So what we'll do is We'll do this, and then we'll say cut mesh transform. So we're matching the global transform. We don't have to do that for the... Ooh, we do want to do it on this one too, don't we? Because we're creating a new one here. So we would want to do the same thing. This is offsetting everything to local cut transform basis. Some funky stuff is going on here. These are our meshes. Object CSG mesh. I see. I see. So we do want to match the transform. So this is going to be transform. Now, is there global transform on CSGs? There is. We're just going to make these exactly the same. Okay. So now the object mesh that has been generated from our mesh and then the slicer mesh both have the same transforms as the cut mesh and the actual lumber mesh itself. So our transform should be right. That means that all this shit can go away. Whoops. If this is correct. Which it might not be. So all of this junk goes bye-bye. Look at this. And everything else seems to be right. Wish us luck. Where'd it go? Oh, look at that. Okay, so we got something, but now our joints and everything got all messed up. Why am I leaning? Am I leaning? The tree is leaning. Oh, the tree did not like that. Look at that tree. Okay, so I think now the issue is our joint stuff is all wrong. But I think we got the cut right. Let's do a really thin cut on one side. We'll do like a little tiny chip. Yeah. So our cuts are right, so our joints are wrong, and our placement and everything. So let's fix that. Smackdown! Ba-ba-da-ba! Da-da-da-da! All right. So now, when we create the lumber, this is where we're doing the collisions and everything. Are we adjusting us in space somehow here? New mesh. What about here? No, look at this. We're doing some transform nonsense. I don't think we have to do this anymore. Let's see if that fixes it. I have a confession, guys. This is how I get through life with everything. I sort of know things, and then I just kind of smash them together until I get something. There we go. We got it. It's looking good. Okay, so now, chess player, what's up? Now that we have this, we, in theory, have a predictable axis aligned bounty box. And we don't have those hanging chads anymore that we were talking about. So we did it my way.
So you're just an old hacker like me, but disguised as an idiot.
Yep, that's right. All right, so let's get rid of our old code. And we actually reduced our line count significantly doing it my way. So now that's smaller. AliMod Co, how's it going? All right, dude's got to run. Thanks for the stream. Glad you got it to see it work. Yes. Now we can do the cylinder. It's going apples and great. That's good. Good to hear. Okay. So we're much closer to what
How
we
much
want.
time is wasted?
How much time indeed. So to get this like perfect to start with, we do know that we can do this, which is, and we don't want to do this, but we could just to get going. We know that if we generate the collision, so we have this screwy model, but we know, no, that's not it. Where is it? Old tree. Here's our screwed up one. This is okay. So if we create the collision shape using TriMesh, we're going to get a very accurate 1-to-1 of the of our friend. So right here,
Fartality.
indeed, create multiple convex collisions. Can we create, so this is on mesh instance. So let's go over to mesh instance. I don't see it. So we're not in all. Mesh instance. You know what I notice is that I probably just need to just bookmark all classes. This is what I'm doing. I should just search this. That's what I should be doing. It's way faster. Okay. So mesh instance, we have create TriMesh collision. So let's do that instead. So we're going to say create TriMesh collision instead. And now we'll have a really accurate collision. But it's really expensive. But this will get us by, and we won't have this problem anymore that we were having before. Whoops, we're trying to cut nothingness. There's our chainsaw floating in space. Okay, we come over here. So look at that. That's very accurate, right? And now it's... What? You okay, bro? This is why we want cylinders, guys. We get some weird behavior with physics right now. It's perfectly balanced on its tip. Okay, I think we're putting... What the hell? What is going on? What? Okay, so again, one of the reasons why I want a cylinder. And this is very expensive, obviously, from a collisions perspective. I can bump up against the branch, though. That's cool. So what is it? Hang on, let's... Let's see here. So we're going to go over here. Let's bring the ground back on. And let's hide the chainsaw because we don't need to show it on the scene. And let's hide or show the ground. There we go. And we're going to get rid of the collision shapes. So now we can see how wacky this looks. Yeah, I think it's a starting point. What are you doing? It's like balancing.
Oh, that's cool.
Fiera with the raid. Fiera, how's it going,
You
man?
think it's cool? It's cool. It's not cool.
Yo, yeah, we just got we made some huge progress on our tree cutting. Still needs some work, still needs some love. But I can show you. Let me come over here. So let me get the go and we can slice it. And it falls down perfectly. Right now, don't pay attention to this. Don't worry about that. That's nothing. What is it doing? Why? Besides that, ignore all that. But we can do any kind of cut. Look at that. The now we're dealing. Why is it gravitating towards this area? It's an anomaly. It's like something in Interstellar. But we can do like a weird angled cut too, like this. We do one like this. See, now we got a nice little slice there, like that. Huh? But we got the cutting working right. The we're working on some other things here. If I go back to the old way, hang on, let me go back to the old way, and it'll fall proper, so you guys don't think I'm a lunatic here. I'm alert for now, but okay, yeah. Take care of my chat. Yeah, I'll put on some Paw Patrol. We'll be okay. There we go. So this is how it's supposed to look. So it's supposed to fall on the ground like that. So, and then we get a little bit of a roll. There it goes. So that's fine. But we want a really sharp collision shape, which is why we're going with the try one. But we end up with some issues. Can I do like a little tiny bit off the, hang on, I'm going to do just like a little tiny corner. Like right there. I'm just going to shave a little tiny bit. There we go. Look at that. I like that it's just like you're cutting into butter. That's, something about that is great. Conrad, how's it going? All right, let me do a shout out to Fiera if I haven't already. I appreciate the raid, Fiera. Pollinate or Die, wishlist it now. Coming soon. You can play the demo right now. It's a flapper, a roguelike flapper. No, it's a Dark Souls flapper game. But it's a really cool game. It's definitely skill based, with a heavy emphasis on a flap mechanic. So if you like flapping it when you play your video games, then definitely check it out. Why does our laser beam get bigger the further away we are from said point? I don't understand that. That ain't right. What happens when we cut the whole tree? Look, this is even right now. That whole piece fell off. It's just resting on its laurels. Oh my God. It's happening. We're making a tree cutting game. Oh my God. Okay, hang on. Can we cut? What happens if I... Okay, okay, now I'm just having fun. Which is a good sign, I suppose. Can I push this? No, it's too heavy. I don't think I can. Ugh. There we go. Look at that. Oh my God. Didn't I tell you it's just like once we get it in, like obviously this isn't how it's going to work, but it's starting to feel like something. Ugh. Ugh. So we can't cut both of them though. So if I do this, I'm only going to cut the one branch. But now I can kind of We can start slicing a bunch of stuff up. There we go. Okay, this is... Hell yeah! Yeah, let me come over here and slice. Dudes! Look at this. The textures obviously flip over and they end up being wrong. We might have to store a bunch of data about where the original texture stuff was in each of the cuts, so to speak, or each of the pieces of the wood. It's white on the inside. Mongolo, how's it going? It is. It's well, there is a tree that oh shoot. There's at least a food that's like this, but not I'm not sure about a tree. It's kind of barky on the inside, and when you cut it open, it's white. What am I thinking of, guys? It's used in a lot of Asian cuisine. Balsa. Yeah, is it balsa that I'm thinking of? Okay, this. All right. Ginger. Ginger is what I'm thinking of. Yeah. 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 Stargate on Amazon. Yeah, I texted a buddy the day they announced it. I was like, "It's coming. It's happening. Calm down." They're filming in the UK, or they're filming in England. I guess I should say. So for some reason they're shooting there. I don't know why. So they're not using Vancouver anymore. So that'll be interesting. Okay. I think we need to share this accomplishment with Discord. Give me a moment, guys. We're having a moment here on stream. Let me put this in the Discord. In the devlogs. Here's a link if you want to join. And I'm going to go grab a drink. I'll be right back. I should grab some food too. Here's what I put. there's what I put in the Discord. All right, I'll leave the Discord up. You guys can do whatever you want in there, and it'll show up on the stream. But I got to grab a drink. I'll be right back. We should get a demo. If there's one with a demo, we should do that. Yeah, I'll be right there, sweetie.
Or try to me. I could put mama
Okay, I'm back. This is exciting. So let's get the texture on the mesh now. We'll get the texture on the mesh. And we'll work on the joint stuff because we can do that now. So we'll work on putting the joints on it, connecting it all together with the joints so that it doesn't actually come apart. And then we can work on the wood chips and we can work on the actual angle cut thing that we've been talking about doing this whole time. And all of that good stuff. We're actually making it now. This is happening. So we've solved sort of a critical problem, or at least we're getting our head around it a lot better. And so now we can actually explore this idea, because right now it's all been in my head of like, it'll be like this. But now that we're kind of seeing what it could be, it hopefully, maybe as we start to work on this after 10 long years. Yep, for sure. So we also need, like, we could probably maybe build an area that doesn't look like this, right? So I think we could do some dives into some of the funner sides of that, but not for the prototype. I think the prototype stuff is, we're still focused on mechanical elements of the game. And then once we get the prototype in people's hands, I think while people are playing the prototype, we'll go back to, okay, let's make it look nice. So, and that's where I think some of that is important for atmosphere and selling it, but not for the prototype. And too, Bob, I think once I have the sort of my microphone's going a little limp here. Once we have the whole cut action going, that's when I can start to throw it your way for sound stuff. So the first thing we need to work on, now that we have this going, it's all the random bugs. Yep. So the first thing that we're going to do is, when we do this cut, we're actually going to assemble everything back together. With joints. I believe we can do this here. We don't need this error check. That's I did an update on oh, by the way, Conrad, I missed I didn't say hey to you. How you doing, man? Munglo, I hope you're doing good too. Dimitri, how's it going? So we know the exact point in space, or close to it, of where the joint should go. Yeah, it's Lazy Vim. I ran an update on it and broke Tree Sitter. Never update anything. That's the lesson here. We have this cut transform. I don't think we need this anymore. Yeah, we can get rid of that. And then we have the cross-section material. This is what we're going to use to recreate or create the texture of the cut. So I actually need to go and find some old code to recreate the... If it works, don't change anything. Yeah, dude, especially anything that's like built off of like a million config files all working together. Just leave it alone. But yeah, my tree sitter is totally broken. So, I'll deal with it in a little bit. I think I have to do a more global update to fix it. Today's Saturday, right? Speaking of Stargate, I run a game with some friends, and tonight is the night. It was in the game code. Oh man, we have to go in the past because I don't think we have game outright anymore, do we? Yeah, we do. Where are you at? Game is in the root. There we go, game. And then we just have to roll back in time. And I think we're talking this far back can get us close to what we're looking for. And then let's just view the source as it was. Okay. And then let's see where the mesh stuff is happening. So there's the bark material, and then there's the wood grain material. Mesh slicer, slice mesh. I have to look at the whole project here. So I know the commit number. Sorry, guys, we're going back in time here. How do you look at the code through a specific commit? Here we go. Here it is. Easy. Okay. Pretty straightforward to get this going again. So on our slicer, we have the cross-section material. This is blank. It's an empty thing right now. This is the material that we're going to use to create the said thing. Now we have a preload for this, I believe. We can just preload it or load it in. If we look for it, I think we have like the bark or something somewhere. Look at all this crap. Tree, satellite, chainsaw. If I'm on a mesh, I can find it, right? So if I go over here and I look at, not the shadow mesh, we're going to look at surface material override. It's called tree bark, or no, wood grain. Wood grain. Assets not for release, wood grain. Copy UID. Okay. We should have this just loaded somewhere, but I think this will do it. I like cheese. Nice. Growling. Nice. All right, so we got our wood grain. It looks like shit, but it is there. The texture's all wrong. Now if we cut something, like let's cut this whole thing. And we have like a grain. Obviously the branch fell. That shouldn't be happening. There's a lot of stuff that shouldn't be happening. But we know how we can do it, so we can do it. Look at that. Yep, we're cutting wood. Okay. So that's easy. Whoops. But it's pretty great so far. It's coming. It's coming. So over on the game, we can just preload the wood grain. Hey, we already have it. There it is. So wood grain material, it's already preloaded. Standard material 3D. So cross-section material, we can get rid of that. We don't have to instantiate it. And cross-section material is now game wood grain. I think that's all we have to do. What is it? Wood grain material. Everything is broken. Autocomplete, all of it. Looks like some indie horror games. Close enough horror games. Yeah, okay. So the preload is gone. Look at how clean, look at how little this is it. This is all that's designed to do the mesh stuff. It's wild how little we actually have to do. I can get rid of this too. Okay. So we're going to try and cut it all and glue it back together with joints. Yeah, I mean, we're on a pretty beefy machine, so the physics calculations are probably coasting right now. We are using Jolt, so that's also a benefit to us. And we're not having to worry about determinism. Now, I think for this release, right, And once we have a tree full of branches, then suddenly, so far it looks like it run on a smart fridge. This is true. So what we'll do is we're going to steal the laser dot position and use this to determine where to put the joint for now. It's not in the right spot, but it's very close to where it should be. So we'll use it for now. It might actually cause a problem that it's not in the center of the points of the mesh. But we'll see. Just filter a couple of local bubbles. Yeah, I'm just not sure with Godot, like how we could do that. But we'll be okay for now. We'll be okay for now. I mean, this is enough to get us to simulate what it is we're trying to do with this. If I don't like it later on, we can fix it because this is, it's enough for the accuracy that we need. So here's what we need to do. When we create these two new joints, we need to now create create these two new meshes. We need to put a joint in between where the cut is, and then join the left and right mesh together on that joint. And hopefully, if we get it right, when I press the button to do a slice or cut, nothing will seem to have changed. All right. What I worry, though, is that there will be an immediate shift, which is actually good if we combine it with the blade coming down and making contact with the lumber or the wood. And as soon as we do that, that's when we do the actual slice and join. And so even if there is a little bit of a give, it sort of lines up with the action of us doing the cut of the saw coming down. Okay, so lumber pieces is an array of lumber. We're creating new ones for each new mesh. And while we're doing this, we can connect. So right here is where we could take and create the joint. Okay. So we just put the lumber joint in that position where the laser dot was. I went to a cookout and got some loaded dogs, came back home and realized the windstorm this morning tore our American flag to shreds. It's like in a movie. It's like you're in Lord of the Rings. Yeah, I used to hang a flag, and in California, and I think twice somebody piked it. They like stabbed a hole through it with the post that it was on. So I kind of just stopped. Like I didn't fly it because it's like, oh, you know, it's just disappointing. Because it's mine. You know, it's mine. All right. Okay. Now we need to connect the joint on both ends here. So we have to take both meshes, and for one mesh, we make it to A. So then we know for a fact that lumber pieces we're going to get 2. So on the lumber joint, node A will pick one, and then node B will pick the other. So node A equals lumber pieces 0. And then node B will be lumber pieces B. So this should get us it. This should be it. Let's see. It's still not set up exactly how we need it because the lumber itself needs to know about the joints as well. But for now, this should get us there. Cookout is a wild fast food restaurant in North Carolina. I got a tray of 2 dogs with chili mustard and slaw. In my sides, I got some barbecue pork. Ooh. Hush puppies. Oh. And a quesadilla. Oh. Banana fudge shake. Oh my God. Oh. Dude. Greg's just making me jealous with all of his foodstuffs. Could not parse global. Line 19 on Game. We didn't touch game, did we? Line 19. What? Couldn't parse global. Oh, chainsaw. Oh, so there's something wrong with the chainsaw code. You know what'd be cool is if I got something here to tell me that. Wouldn't that be cool? Wouldn't that be cool? Ooh, and we need to add the joint to the scene tree. Let's close and reopen this. And maybe we'll get some... Hey, there we go. Oh, we're already using the term lumber joint. That's what it doesn't like. So we'll call it new lumber joint, like New York City. And then these need to be on their node, the node paths. Okay. Cross your fingers. Oh my God. Okay. So that's it. Now we can have joints that are connected. And then now we can work on, we need sawdust. We need to have the mechanic of we're bringing the chainsaw down. We create the joint. And then we start to subtract from both sides of the mesh for the blade itself cutting into it. And we know how to do that already, right? So I'll have another mesh that matches the exact shape of the blade. Okay? And then as we're cutting in, the only time we actually have to do the subtraction from the neighboring meshes is when we release. Curve me up, buttercup. Oh, Fiera, your stream's still going. Uh-oh. Hopefully he's not polishing his wood right now. Can we DDoS Fiera's stream and get it to go down? Is there some way we can... I hear you through his stream. Uh-oh, toilet stream. All right, let's see where the joint actually is in 3D space right now. Just to make sure it's kind of where we expect it to be. So if we look at the remote scene, we should have a new joint here. seems about right. Where did we make the cut? Yeah, the cut's right there. You can kind of see it. Okay. Yeah. Seems yep. Cool. Holy moly. So I think the more accurately we place that joint, the less we're going to have of that bounce that I was worried about. But that it starts to lean at all is actually accurate to what we're trying to achieve here. So now we can do what I was talking about, which was, maybe we can do it now. Like we can make this fall right now if we wanted it to. But if we turn, yeah, see if we turn off, isn't that weird? Look at that. Whoop, 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 whoop. So if we change, I forget what forces we were changing. Let me look at my code for this. But I could simulate how the break would happen right now. Can't remember. I think it was like 3 different things that I changed all at once. So, oh, this is all coming together rather quickly. This has been like 4 days of me working on this and feeling like I'm not getting anywhere. Angular on all 6, yeah. It was on the branch code. Here we go. So we were setting the Angular upper and lower limits to a value that I had on a slider. This is how we were getting it. And then we were comparing the dot product. This is your suggestion, to Bob. I was comparing the 2 dots of the bounding boxes. And if it was a certain amount, then we would queue free the joint itself, and then the entire, both the branch that was on the one side would just fall. So I think it would be fun to try and work on, the sawdust. Now, these are bigger chunks than what you would see with something like a table saw. Because the chainsaw, I mean, it's a chain, but it's in the name a little bit, right? And so if you look at a chainsaw, if we go over here and I bring it over. You son of a bitch. You're like, oh. So the cutting thing of a chainsaw is you've got this like these 2 blades. Then you have this like outer thing here. I think this works as this is what hooks into the mechanism. This is what does the actual cut right here. So it's real raggedy. It's more like you're grating cheese than you're using a strictly like really sharp blade with like the so we need like it's like shaved chips. You had me at cheese. See, if I search wood chips, we're going to get this crap. This isn't what we want. So we're going to search shaved wood chips. Yeah, so this is closer to it. So somebody's selling shaved wood chips on Etsy. I am in the wrong business. What in the ever-loving fuck? I'm sorry for cussing. What? What is this? Here we go. So what I'm imagining is something like this. I think I'm still going to, Bob, I think what we'll do, it's for hamsters. Oh, that makes sense. It's probably cheaper here than it is. Like you probably pay like $100 at Petco. That's from planing. Yeah, I agree. But I'm just thinking for the look, because we're just gonna explode these out, flying out. Let's see. Chainsaw wood chips. That's right, honey. Someone's poor daughter has to use a chainsaw because her dad didn't get a son. I would randomly deform a cube. I think I'm just gonna use particles, and it'll be in 3D space, but I'll just throw a bunch of these in the air. And we'll instead of having them be billboarded facing us, we'll turn them into flat don't align to the pretty flat things don't align to the verts to the corners. So let's start here. And it won't let me. We're going into Jesus. Don't I have ad blocking on? What is this? Let me double check my ad blocker, make sure it's running. Should be network wide. This is awful. My sisters built me a fort in the woods with a chainsaw when I was like 7. They were 13 and 16. They just wanted to play with a chainsaw. They came up with a legit excuse. Like, Dad, we're going to use the chainsaw to make a fort for Greg. I'm going to restart my ad blocker because it's showing 0 block domains right now. And this is an outrage. Nope. These must be on the Jesus Christ. Look at this. I'm getting slammed hard. What is going on? Hi, Emily. This is Emily's blog. Oh, that must be Emily cutting the. All right. That's more adverts than I've seen in 35 years. Okay. I just want the damn wood chips. Okay, we'll do the print screen. How about that? M's like, hey, it's me. Amberly Love Hewitt. Okay. So it's basically like it's just like zigzaggy. It's like if we take a wood grain texture and then we just sort of zigzag it on the ends. It does depend on the wood too, I suppose. Raggedly deformed quabs. Medusa tea. Medusa. Look at this. Look at this, Medusa. Oh, Medusa, you can't see it right now because we're in the middle of something else. Hang on, let me disable the joints. It's because we're making progress that you can't see the coolness. So we're just not going to add this to the scene. That should do it. We're looking at wood chips right now. There we go. Look at that. And then over here. We'll cut it underneath. Oh! That would happen because... Okay, so we have to fix that. All right. Sorry, guys. Back to it. Anyways, cut that. Go over here. Cut this. So you can see it works. Come over here. Cut this. And then we can come over here and slice this whole thing down. So we can go like that. Oh, God. And then on the ground, it's on the ground. We can go, oh, and then slice that. Now, the mesh is wrong. So not the mesh, but the texture gets wrong. So what we're working on right now is the actual act of cutting. Sick. I need to do the reverse of this where meshes join at runtime. Oh my God. I'm doing my own sound design right now with my geese and I keep going, wait, I didn't add chainsaw. Are you in Godot? What are you doing it in? Because I could help. I believe I can help. That would be a union. So if you're in Godot, you would need a CSG combiner. You would take the two meshes, get them to overlap by some amount, and then you would do a union on both, and then you would from the CSG combiner, you'd save that as a mesh, and you should be golden. That's what you do. You just line those two sons of bitches up and be done with it. So, and to prove that, if I have this box here and I stop it from being a subtraction and I turn it back to union, and then we turn the, let me get rid of this. And then we turn this cylinder into union. It should be on union already. Yep. And then I save this mesh. I have this custom little button here. I save the mesh. And now I believe it's under new mesh. Is that what the save does? Let me see. Yeah, new mesh. So if we go over to game and we add a new mesh, I believe we have something over here to test this. Yes. Sorry, let me get this out of the way. Oh, it replaced it. Here it is. So here's the mesh. And if we look at the whole thing, let me move it up. We go like this. Let me bring it up. This should be, yep, there it is. So you union the two together, and now you have a single mesh. And if we look at it from our wireframe, this is what it ends up looking like. So, yeah, you should be able to do it. Now I have a more confident understanding of this whole thing. And I think I'm going to make Godot crash there. Here's some other wood chips from... Oh, the chains create different wood chips. Oh, my chainsaw is dull because this is what my wood chips look like. How do I call that function? It's not a function. It's a mathematical operation, I think is the way to think of it. And so what you need is, okay, here's what you have to do. I'll break it down for you, like the whole thing. Okay. You would need a CSG Combiner 3D somewhere on your scene tree. Just leave it there if you're going to be doing this often. Then you have your, you would do a CSG Combiner 3D. Now, you would do a CSG Mesh 3D, two of them. You do two of them, okay? And one of them is you're going to set the mesh of the CSG Mesh 3D to the one mesh, and then you'll set the other one to the other mesh. And by default, their operation is set to union. So long as they don't even need to overlap technically. If you do a union, now when you take your CSG Combiner 3D and you go, so we have, how do we do this? How am I doing this? Meshes equal get meshes. So on CSG Combiner, you would say get meshes. They're on a union already. So this gives you an array of your meshes. You need the second value from the array. And then you would save that. Or in your case, you wouldn't even save that. You would just take that. That's an array mesh. And now you have that array mesh is both meshes together. If you do a union, then they're married and they have to kiss. Exactly. That's very funny, but not true. Yeah. So yeah, you put them together. So like for instance, if I just grabbed a mesh that I have somewhere, like my chainsaw mesh, and put it on this one. Is it this one? I don't have a material. Do I need a material? Standard material? Where's our chainsaw mesh? Is it tiny? I chose the mesh. Maybe you don't want to do this. You should be able to do this, though. Hang on. I don't know why I'm not getting... Anyways, I'm getting distracted. Split mesh. Here we go. So I could load that in. Yeah, but you would say on the mesh 3D, you would set the mesh to your mesh. And they both be union. And whatever you have on that inside CSG Combiner as children, you can then get the array. You can get the meshes. And it's the second value that you would want. And that would be the combination of everything. Okay, sick, thanks. Yeah, when I get it back to my game, my slime game, players will be merging and separating. Oh, cool. Yeah. Glad I could help. Back to it. So we want to get our joins going again. I'm feeling good, guys. This was like 3 days of me, and it sucks too because I can't stream as often. So it was like 3 days spread over multiple days where I was feeling like, I don't know. But now I'm feeling less about I don't knows. Okay, so we're adding the joint back on it. And we've got to get we're working on sawdust, right? Why are all the pictures like taken in 1990 on a digital camera? And here's the question. Where does the chainsaw... So it spits out towards the cutter. Which makes sense because the blade is pulling it forward. And so the sawdust would come out shooting down from the bottom. So we want the sawdust to protect from the chainsaw. It would come from... So we know where we're going to put the emission of this. So it would come from back here. Okay. And it seems to spread out. Okay, we got an idea. We want gravity to play a part in this. Excellent. These high quality images for helping us determine whether a chainsaw blade is dull or sharp. Gold. Yes. Okay. We can get something out of this. This guy right here. Candidate. Oh, candidate. Do 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 do. This one's pretty good too, right here. This one's pretty good. You know what? Let's go with this one. We'll do something like right there. .256 by 256. Custom document. We're watching a movie about a kid who enters a paper airplane contest. And it's cute because the there's a girl who's supposed to be visiting from Japan. And it's super cute because she has an Australian accent when she speaks in English. And it's great. It's super cute. But I guess that's better than just having her be like, okay, sound more like from your native country. Because she's supposed to be visiting. She's not like from there, right? Anyways, I don't know why. It's cute. How do we how do I rotate this some bitch? A mini game? Hell yeah, that's why you do it yourself, and then that's why you hire workers. So you can keep doing it, but it might be better use of your time to have someone else do it, right? All right, we'll do the 256. Okay, and then we got to erase all this. How you doing? We should all allow each other to have a kill switch on our stream, just in case we accidentally keep it going when we're not there. Might be a good idea to program something in OBS for ourselves, where if the image of the scene or something hasn't been changed or something, we can just be like, hey, you're probably not there. Maybe have a prompt. And then kill the stream. So you're saying use a quab to Bob. Okay. Now we'll come in with a little bit more grace and we'll use an eraser. which is very clearly this one here, right? Is it just the brush, but we change it to an eraser? It's very clearly... There we go. Okay. We need like a dead man switch for streaming. Guys, and my stream station is in my room, so you can imagine, you know, being married, what might happen in a bedroom that you don't want to have happen on a stream. You know, might be a good idea if I figure something like that out so that I don't get my playing checkers. Yeah, exactly. Just a very aggressive checker playing. Super aggressive checker playing. This is something that we could have that's a very visual indicator that our chainsaw needs to be cleaned, is that it could just come out as like a little pixely powder, right? And if you don't see big chunks coming out of your chainsaw and it's just a dust, then you know that your chainsaw needs to be cleaned or that sharpened. Okay. There's our wood chip. Scale it, yeah. Okay. We'll see how far we can get with this. Chainsaw wood chip. Can you not select by color? I'm sure there is a way. I don't know how to do it on this. So I'm not gonna... We'll get something going. So on our chainsaw, now we're gonna I'll just throw this over here. Okay. So we'll just create same deal as before, but now we do want gravity play a role in this. And GPU particles, so we're going to lock it inside of this. We have our shake node, so it's going to be on the shake. We have the mesh. So now we're going to create a new GPU particle. All right, and then we're going to line it up. So we want it to be somewhere back here. We don't know exactly where. Let's go right view and up and forward. So probably right there. So it goes through here and then it spits out right here. Now I'm wondering if... No, it doesn't represent. Okay. All right, so let's see here. We're going to... Process material. Check. Draw passes. Pass one. So do we just do something like a plain mesh? And then we just kind of twirl it around? Is there something a difference between a plane and a quad that makes it one better than the other? One, I don't know. Orientation. We're not going to care about that right now. We do want this to be billboarded, but I believe that we don't want it to face us always. So maybe we don't billboard as a particle. Deform. Are we going to notice it with how fast they're coming out, though? So we would do some sort of quad that we have like a bend. You can deform a plane. Okay. All right, we'll figure that out. Standard material. I guess we have to have that billboarding no matter what. I'm wondering if quick load. Did I not save? Oh, I did it as a document. I didn't do it as a PNG. There we go. Perfect. Ship it. Done. We got it. Yeah, I'm trying to see how we can adjust the billboarding. Let's keep going on the emission stuff, and then we'll see if we can fix this. Face Z. Is that what we want? But let's I'm not going to change. Let's get the scale right. What do we say? Divide by 10? Mount 64? So then we have the ratio, which will change it as over lifetime. Let's see here. So we're going to do process material. Here we go. Particle flags. Okay, let's go back to the material again. The draw passes here. We're going to put this back on our traditional. We're going to reset this here. And on our material, we're going to say we're particle billboard. Okay, that's good. Now we have process material, particle flags. Get rid of the draw passes. Align Y. I don't know what that does. Rotate Y. Seems to do nothing. Okay, so I do like how it looks with the face Z. That seems to be something that we want. Spawn, position and angle. Emission shape. Okay. Sphere. Ah, I see. So we come out from a specific point. What does directed points give us? Oh, wow. Okay. Angle. That's our angle. And that's just the starting position, right? So that's not a velocity. Spread. 45. Let's see. Flattenish. Initial velocity. Woo! Why are we coming out all on one side? Is that our 45? Okay, we're just exploding out of this son of a bitch. Ooh, what is this? Because that's more the angle we want. Radial. Directional, angular. Pull down on the initial velocity. Yeah, yeah, definitely the early velocity is too much. Lifetime. Collision might be a good idea too, but that's a lot of... Let's try and get that initial velocity fixed. So we do have a gravity. We might as well... So our scale is just too big. Let's cut it in half one more time. Lifetime, if it's coming out a lot and we shorten the lifetime, so 128. And then if we cut the lifetime as well, we get more. If we do like half a second. We need that spin. We need the speed to slow down. Velocity. Here's our direction. Ah, okay, so let's reset our transform. Our rotation. And now we can fix the here we have direction. So we're coming off X. We want to come straight down from, well, it'll be a combination of things. So we're X on the positive. This would be Y or Z. This would be Z. Now we're all over the place, right? Yeah. So we want to come off of Z or not. Why did the X do that? Negative on the Z? There we go. Get rid of the X. Okay. All right. Now we want to angle the Y. Is it the Y? Or the X? I guess it's the Y. And we want to go the other way, negative. Okay. So now we're starting to understand things a little bit more. That's looking pretty good. Now our scale is still way too big. And I think we can cheat with showing multiple chips on a single texture. Maybe if we have multiple textures, maybe we can get away with that. I don't know. The emission's still too wild. Now this is direction, but this isn't the velocity. Inherent velocity ratio, velocity pivot, spawn. Angle. What is causing this velocity to be so wild? Is it these two numbers here? If we just keep dividing them down, do we get lower velocity? So our spread is 45. I can see that right now. So if I made it 90, yeah, okay. So I'm understanding that. Is this our velocity? If I keep dividing this by 2, does that slow us down? I think it does. Problem is we have gravity already. So if we're spawning with gravity, it's going to, maybe we should lower gravity. And maybe it should be lower gravity because these are wood chips. So they would be kind of lighter and the wind would catch it more, right? Still trying to lower that velocity down. Nah, they don't hurt. They're really wet. The wood chips from cutting from tree. If the tree's alive, the wood chips are like wet and sticky. Arborist videos for reference. Yeah. Initial velocity. Yeah, where is that? Let's do a search. Spawn velocity, animated velocity, scale over velocity, turbulence, sub-emitter. We're not doing that. Oh. That's me. If we go back to 0, we're the same coming out everywhere. What happens if we go negative number? This is our velocity range. So we want to be close to 0, right? Velocity curve. Animated velocity. If we did a velocity curve, we could have the velocity kind of slow down as it's coming out. Under flatness. Let me see. Explosiveness, speed scale. Here we go. We can see it in slow-mo now. Okay, so now I have something I can work with to get the spinning right. It was right there on that screen. Let me search. Flatness. So now it's kind of shooting out the same everywhere. Yeah, it's more flat. And then if we bring it back, it starts kind of going out all over the place. And initial velocity. Can we go negative? No. Initial velocity. Orbit. So we don't want orbit. Radial, I think, has to do with. Whoa. Oh, it's behind the chat, or it's behind me. Move myself over here. Slider above. Lower the max. Max. Oh, dang. It's barely even noticeable. There it is. You found it. Okay, so let's get our speed back to normal. There we go. Starting to look like something. I almost think the entire thing being semi-transparent would let light through as though it was thinly cut wood. So that we have on our albedo for the texture, we go and we make it a little bit transparent. So that it kind of, you won't be able to see it very noticeably, but it might be pretty costly. I mean, we're already technically doing a transparency. Yeah, I agree. It's still too large. I don't think we can go much lower on our size where we might need to, oh, that's pretty close. Only bummer is right now we wouldn't. Let's see what it looks like. We're just going to bust the chainsaw out. It's going to be spitting them at us right now. Look at that. Gravity's pulling it down. So even if we were cutting at an angle. And then it would just be coming out. I mean, that's something. I think that's good enough for now, but it definitely needs a lot of work. So I think for prototype phase, this is fine. And so now we just need this to be something we can turn on and off. Vex, what's up? So we'll say wood chips. And this will always be emitting, or we just turn the emission on and off. So whenever we start cutting, and we can have it ramp up and stuff like that, but we're not going to worry about it just yet. So, and then you stop. And then you stop. Randomize the particle size. Oh, that's another cheap free one thing to do as well. So that's on spawn. Emission shape scale. No. Velocity. Angular velocity. Acceleration's gravity. These are the ones we were talking about. Linear. Oh, no, we don't want to do that. Is it the radial? I think the radial velocity. No. I want it to spin. What the hell's that one? Scale. Scale over velocity. Interesting. But no, we want to have it be different scales. So we'll say 1 to 2. Did I screw something up? I think I screwed something up. Why are we all screwy right now? There we go. Scale 1 to 2. What if we make it even bigger? Seems the same all around. Is it the other way around? Minimum? Nope. Huh. Do we need a curve? That's scaling over time. Scale over velocity. Is our number so small that it just can't? Turbulence. Size? Is that a word in here? No. Scale. Spawn. Position. Shape scale. This is doing jack diddly jack. Shape scale. Billboarded. Keep scale. What was that doing? None of this is doing anything. Maybe I want to have, if I'm going to do scale. Oh! If I'm going to do scale, maybe we do it. Okay, that's doing something now. Okay. So let's change this down to like 0.125. There we go. And now if we scale here, so if we don't change the scale here and we do it in the emission, maybe that's what it is. Yeah. Okay, so okay. Starting to look like something. Now if we scale over velocity. Interesting. Okay. Collision, blah, blah, blah. We're not doing any of that. Damping. I want them to spin. You know? Yeah, no, that's right. I was just trying to see if it would do anything. Let me slow it down. See if we can slow it down. I mean, it seems all right. Is this something where we could lower the FPS to and it would look okay? Because it's going so fast. Okay. Now, on the chainsaw, we're going to go ahead and turn on, or we need an export for this. Wood chips, GPU, particles, 3D. Okay. Now we have access to wood chips. So if we're holding down the button, we can do this on set state. So when we set the state to cutting, do I have to set emission? Emitting equals true. And I guess everything else we just put it to false. And by default, it's just off. So we just turn it off. Let's try cutting. Okay. So you want the occasional very specific. I know it's looking good. I think it probably look at the lighting. I almost don't want the wood chips to be shaded, but I think that's probably a mistake if it's a darker scene. So you see the problem there. It picked the wrong side for the joint. So that's a bug. So we're going to have to do something a little more complicated to detect that. Let me see if it happens on the side. I think it swapped the joints. Okay. That explains why this is still broken. Like if we cut the tree. Wonder if it's weird that it's falling at all, though, actually, because it should be making joints for them. Kill Bill, look out. So the joint thing works right here, but it's not working here. think the joint stuff is going to need some work. I think I'm fried. Ladies and gentlemen, we're going to end the stream. It was only 3 hours. It's the weekend. I got to be with my family. I'm going to trust my instinct on when my brain dries up. Let's go ahead and raid Fiera. Should we raid Fiera? Where's his stream? How many viewers does he have just not doing anything? Oh wait, is he back?
Okay. Okay. I was just lurking too hard, man. I was lurking too hard.
All right. He's back. He decided to continue. Might as well continue. That's so funny. Let's raid Fiera. We got to raid Fiera just to keep the cycle alive. All right. Well, raid Fiera. Much love to everybody out there. I'll see you guys later. Bye-bye. Any minute now, I'll be able to hit the button. I should leave my stream open on accident, right, guys? Wouldn't that be funny? All right, see you guys.